Descriptive statistics. Most of the statistical information in newspapers, magazines, company reports, and other publications consist of data that are summarized and presented in a form that is easy to understand. So here, you're summarizing data. You're going to do it with a table, a picture in the form of a graph, or some number that describes this set of data. So here we're going to be looking at the manager of Hudson Auto Parts would like to have a better understanding of the cost of parts used in engine tune-ups performed in her shop. She examines 50 customer invoices for tune-ups. The cost of parts, rounded to the nearest dollar, are listed on the next slide. You can see we have this data here. Now, one of the things we want to look at is what is the lowest value. The lowest value on this chart appears to be around $52. The highest is 109. So we're going to set classes up for cost for these data. So we might start at 50. That's less than 52, so this lowest observation will be included. Go up to 59, then start the next class at 60. Go to 69, 70 to 79, 80 to 89, 90 to 99, 100 to 109. There are different ways, which you can read about in your book, on how to set these classes up. Then we're going to go back through this data set, and each time an amount for the cost of a part falls within 50 and 59, we're going to make a little tick mark and keep track of them. So 57 and 52, we have no other parts that cost in that 50 to 59 range. So we have 2 parts that ran in that range. We call that 2 the frequency, the number of times it occurs. The next thing, 60 to 69, we could go through this data set. We find out that 13 parts cost between $60 and $69, and we do that for all of the parts on that chart. Then we add those up, and that gives us a total of 50 parts that we looked at in this survey. To calculate the percent frequency, you simply take the frequency of the class, 50 to 59 is the class, 2 times is the frequency, divide that frequency by the total frequency, which is the total number of parts we looked at. 2 divided by 50 is 4%. 0.04, we convert that to a percent. 13 divided by 50 is 0.26. Convert that to a percent, that's 26% of the parts cost between $60 and $69, so forth and so on. Key things to remember, your frequency has to add up to the number of parts we looked at, and your percent frequency has to add up to 100. If it doesn't, you could have just made a mistake calculating the frequency here, or you could have a part that was less than 50 or a part that was more than 109, and you need to redo your classes. Here's a histogram. All we did was graph this information from this chart and make a picture of it so people can more easily understand it. One thing, when you graph, you always want to make sure you label your axes. Here I have part cost in dollars, 50, 59, 60, 69, so forth and so on. Here I have frequency, 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. You have to do this or someone will not understand what they're looking at. And then I have a title here, tune-up parts, and I got a 0 here for my origin. Okay, two of the parts cost between 50 and 59, so I make a bar. I go up to 2, over to 59, between 50 and 59, color that in, that becomes 1 bar on my histogram. Then 60, 69, I start at 60, I go up to 13, go straight across, make a bar, go down, that becomes my next bar. This graph is very important as it gives us an idea of what the data from our data set looks like. You can see it's sort of clustered or tends towards this 70 to 79. That brings us to the next slide. Numerical descriptive statistics. The most common numerical descriptive statistic is the mean or the average. We all know how to do this. You take some number of observations, say the number of heights of 4 people we see in the class. We add those heights together, divide by the 4 people. On average, we would get some number, which is the average height of the class. In statistics, we call that average a mean. The mean demonstrates a measure of central tendency, or where this data is clustered around. Here you can see it's clustered around this 70 to 79 range here. We would calculate an actual numerical value for where that data is centrally located or where it tends toward. And in that previous example, if we added up all of these observations divided by 50, we would get an average price of $79 per engine tune-up. Statistical inference. Here, we're going to use a sample, which is a subset of the population, to try and estimate or infer about the population. The population is a set of all elements of interest in a particular study. For example, if we were running for election, we might want to find out how our candidate is doing. We couldn't go out and sample everyone in Etowah County. That would be our population. So instead, we would take a sample, a subset of the population. Statistical inference is the process of using data obtained from a sample to make estimates and test hypotheses about the characteristics of a population. So maybe we stood out on the corner of, say, downtown Gadsden on First Friday, and we asked we asked 70 people, who are you going to vote for in the upcoming election? We would use that sample of 70 people to infer, as long as we did our study properly, about the population as a whole on whether or not our candidate is going to win. A census would be if we collected data for the entire population. A census is easy to understand. The U.S. Census, they collect data on every single person who lives in the United States. That's often very costly, so we can only do a sample. There, a sample survey is done where we collect the data for a sample, like standing out on a street corner during First Friday and asking 70 people who they're going to vote for in the next election. There is a process of statistical inference. Step one, and you must know these. Population consists of all tune-ups done at Hudson Auto. The average cost of parts is unknown. So population consists of all tune-ups. We don't know the average cost of the parts. Step two, we sample 50 engine tune-ups. Then the sample data provides a sample average part cost of $79 per tune-up. The sample average is used to estimate the population average, what we actually spend on average for a given tune-up in the population. Analytics is a scientific process of transforming data into insight for making better decisions. We have descriptive statistics as one technique. This describes what happened in the past. We have predictive analytics. We use models constructed from past data to predict the future or to assess the impact of one variable on another. And we have prescriptive analytics, a set of analytical techniques that yields a best course of action. Big data and data mining. Big data, large and complex data set. We have 3 V's of big data: volume, velocity, variety. You can read the definitions here. We have data warehousing, is a process of capturing, storing, and maintaining the data. If any of you have read the news lately, many of our online social networks data warehouse on us. They keep information of where you are, storing it, maintaining it, and then they sell it to other people. Okay. Data mining, methods for developing useful decision-making information from large databases, using a combination of procedures from statistics, mathematics, and computer science. Analysts mine the data to convert it into useful information. The most effective data mining systems use automated procedures to discover relationships in the data and predict future incomes prompted by general and even vague queries by the user. Ethical guidelines for statistical practice. In a statistical study, unethical behavior can take a variety of forms, including improper sampling, inappropriate analysis of the data, development of misleading graphs, use of inappropriate summary statistics, biased interpretation of statistical results. Here, this improper sampling, if anyone was aware of what happened in the last presidential election, every survey that came out said that Hillary Clinton was going to win and gave Donald Trump a very low, less than 5% chance of winning the election at the beginning of the day when the election was held. This was due to improper sampling techniques. Democratic Party officials informed statistical survey takers of methods they wanted used to sample the population. Much of this included oversampling subsets of the population which were more likely to vote for Hillary Clinton. This resulted in a biased survey, and of course, we all know what happened. Donald Trump won in a landslide. The American Statistical Association developed a report, Ethical Guidelines for Statistical Practices. It contains 67 guidelines organized into 8 topic areas. You can see those listed here. And that is the end of Chapter 1. Thank you for listening.